Hello again everyone, welcome back to MA 1203 Business Mathematics 2, and this series of video will be your last topic of differential equation. In particular, we will learn about linear second order differential equation. We will start with the autonomous one. Okay, so this is the general form where we have y double xn plus a1y xn plus a2y equal to b. Yeah, remember this is linear because all y, both the original y and also the derivatives are all in at with degree 1. It is autonomous because we don't have variable t explicitly in this equation, and it is second order because the highest derivative is the second derivative, which is this one. Yeah, and of course a1, a2, and b are all constants. Okay, so if b is equal to 0, yeah, just like the other equations that we have, yeah, if b is equal to 0, then the differential equation is called homogeneous, right? And the solution of this homogeneous equation is called the homogeneous solution, yeah, which is denoted by YH, yeah. So it is a homogeneous solution. Okay, but then if we want to solve the complete equation, it will be called the particular solution, and it is denoted by YP. In general, yeah, the solution will be YT, yeah, equal to the homogeneous solution plus the particular solution. Okay, so how to get the homogeneous solution? Yeah, so we have this homogeneous solution on the right hand part, on the right hand side is equal to 0. Okay, and now we let the solution will be C, a constant, times e to the power of RT. Yeah, so this is for differential equation. Remember, for difference equations we suppose the solution in a different form, right? So what was it? Yeah, so try to remember, yeah, and try to differ between difference equation and differential equation. Okay, so now if yt is equal to CERT, and in the homogeneous form of the equation we have this, of course we have to find both y accent and the y double accent. Yeah. So what is the first derivative of this one? Of course, it's gonna be r c e to the power of rt, right? And then for the second derivative, we have to take derivative of this one, and we have r square c e to the power of rt, right? And now we substitute back all of this to the homogeneous form. Okay, so substituting back, we have y double accent, which is r square CERT, and then a1 times y accent, which is this one, and then a2 times y, which is this one. And of course, you can take out the c times e to the power of rt, yeah, and this is all equal to 0, right? Okay, so when will this be equal to 0? Of course, this one, yeah, when c is not 0, this one cannot be 0, yeah, because this is e to the power of rt. Of course, it will not be equal to 0, yeah. Actually, it will be a positive value, yeah. And if c is not 0, of course, the only one that can be 0 is this one, yeah. Okay, so this one, yeah, is called the characteristic equation. And as in the second order difference equations, we can find the roots, yeah, of this characteristic equation, yeah. And the homogeneous solution will depend on the roots of this characteristic equation, yeah. So if there are two distinct roots, yeah, real and distinct root, yeah, then the homogeneous solution will be C1 e to the power of R1t plus C2 e to the power of R2t. Remember, originally we let the solution will be this value C e to the power of RT, right? And then we get, yeah, the R is actually R1 and R2, yeah. So if we substitute back and then we use both of them, the linear combination of both of them, we will get this. What about if they have the same root, yeah. So r1 is equal to r2 equal to r, then of course it will be c1 e to the power of rt. The second term supposed to be c2 e to the power of rt, but to differ with the first term, we have to multiply with t as usual. Okay, so that's the homogeneous solution. What about an example here? Yeah, so let's see this example. We want to solve the homogeneous differential equation y double xn plus 5y(xn minus 6y equal to 0. Yeah. Okay, what is the characteristic equation? Yeah. So remember, we let y is equal to c e to the power of rt, right? Yeah. And of course, y(xn is equal to what? r c e to the power of rt. And then y double xn is equal to r square c e to the power of rt. Yeah. If we substitute, we will get r square c e to the power of rt, yeah, plus 5 r c to the power e to the power of rt minus 6, what is that, c e to the power of rt. Yeah, and then this is supposed to be equal to 0, and then of course we can take out the c e to the power of rt, yeah, and what's remaining is r square plus 5r minus 6 equal to 0. Yeah. Okay, so of course the characteristic equation will be this one, which is r square plus 5r minus 6 equal to 0. Yep. Okay, what about the roots? Yeah, can we factorize this? Okay, so we factorize this with what? R plus 6, r minus 1, right? Equal to 0. And of course we have two different roots, which is r1 equal to minus 6 and r2 is equal to 1. Okay, so the homogeneous solution is what? Y equal to c1 e to the power of r1, which is minus 60. Yeah, remember, this is what we suppose the solution is. Yeah, plus c2 e to the power of 1 times t, so e to the power of t. Yeah, so this is the solution. All right, what about this example, right? And again, we have to find the characteristic equation. Yeah, you can do the similar thing as like we have done before, and at the end you will get the characteristic equation will be r square minus 4r plus 4, which is equal to 0, right? Okay, so next step will be to find the roots. Yeah, what are the factorization of what is the factorization of this equation? We will have r minus 2 square, right, equal to 0. So in this case we have r1 equal to r2 equal to 2, right? Okay, so remember, if we have two roots which are exactly the same, then the solution will be c1 e to the power of 2t plus c2. It's supposed to be e to the power of 2t, but to differ with the first term, we have to multiply with it, right? Okay, so this is the second example. Okay, so that's for homogeneous solution. What about for the particular solution? Yeah, so now a steady state value is a solution where the y is stationary. Yeah, in this case, yeah, we have both y(xn) and y double xn is equal to 0. Yeah, okay, So the steady state value, as usual, will be denoted by y bar. Yeah, and if we put it back, if we substitute back to the original equation, we will get this one, the y double xn is 0, the y xn is 0, and then here we have a2 y bar equal to b, yeah, and of course y bar will be equal to b over a2, yeah, and this happen when a2 is not equal to 0. When a2 is not equal to 0, we use another another method to find the solution. Okay, so we use the steady state value as the particular solution, yeah, and we have this yp is equal to y bar equal to b over a2, right? Okay, let's see an example. Yeah, but remember here the general solution is what? The general solution will be yh, yeah, the homogeneous solution plus the particular solution. Okay, let's see this differential equation. Yeah, as usual, we have to find the characteristic equation. How to find the characteristic equation? Of course, we let the solution y to be c times e to the power of rt. Okay, so if you use that assumption, then you will get the first step, of course, you have to find the homogeneous solution, yeah, and this is the homogeneous equation, yeah, where the right hand side is equal to 0, and then you can find the characteristic equation as I mentioned before, yeah, but by letting y, the solution will be equal to c times e to the power of rt, yeah. So if you substitute all the y, yx and y double xn, you will get the characteristic equation, yeah, like what we have done before. So this is the characteristic equation, r square minus 5r plus 6 equal to 0. And of course you can factorize this, r minus 3 times r minus 2, yeah, and of course you will have two different roots, which is 3 and 2. Okay, so the homogeneous solution will be c1 e to the power of 3t plus c2 e to the power of 2t, yeah. What about the particular solution? The particular solution, yeah, will be equal to the steady state value, which is b over a2, yeah, 24 over 6, and we get that it is equal to 4. And in general, the general solution will be the homogeneous solution plus the particular solution, which is equal to c1 e to the power of 3t plus c2 e to the power of 2t plus the particular solution, which is equal to 4. Okay, so I hope you understand how to find the general solution of a second order linear and autonomous differential equation. See you in the next video.